In this video we're going to complete example 1 and we're going to perform some operations on fractions, but to be more specific it's going to involve some negative fractions. You can already see that in question A we have the negative fraction -1/5. Now I'd like to talk about that for a little bit. When we look at this fraction -1/5, you will notice that the negative is in front of the vinculum bar. Now it doesn't have to be there, there's other places it can be. It could be in front of the 1, it could be -1/5, or it can be in front of the 5, it could be 1/-5. These three fractions all represent the same thing. So the negative can move positions. When we do question A, it really helps if we move the negative in front of the numerator. So let's make it -1/5 plus 3/5. It makes it a little easier to work out. Now, when you add or subtract fractions, the denominator stays the same. Both denominators have a 5, so our solution will have a denominator of 5. And now we're going to go -1 plus 3. And we're going to do it on the number line below. We start on -1, and to add 3, we move 3 places to the right, landing on 2 or +2, meaning our solution is 2/5. Let's now look at question B. You'll notice this time we're adding a negative fraction. And we mentioned earlier that whenever you're adding a negative, it's the same as simply subtracting. So let's rewrite this so that it says 1/3 minus 5/6. It's much better to have a single sign here, a subtraction sign, rather than having two signs as we had above. Let's now work it out. Now the denominators are different, so what I'm going to do is I'm going to take the first fraction and I'm going to times both the numerator and denominator by 2. This will give me 2/6, and that's a lot easier when I'm trying to subtract 5/6. Now the denominators stay the same, they stay as 6, and now all I need to do is go 2 minus 5, and I can do that on the number line below. 2 is my first number, so I'm starting at 2, and subtracting 5 means moving to the left 5 times. 3, 4, 5, and I land on -3. So my numerator will be -3. Remembering we can rewrite this if we want to. We don't have to. You can rewrite it as -3/6, where the negative is in front of the vinculum bar. You can have it in front of the numerator or even in front of the denominator. I should also point out that we can simplify our fraction. -3/6 is the same as -1/2 or -1/2. We have two more examples that we're going to go over here. You'll notice that they're getting tougher because we've got some mixed numerals. Now, because we're working with negative numbers, the best way to tackle this is just to convert all the mixed numerals into improper fractions. And we do that by timesing first and adding last. Let's look at the first mixed numeral here. 4 times 1 is 4. 4 plus 3 is 7. So our numerator is going to become 7, and our denominator stays the same, it stays as 4. You'll notice that our mixed numeral was a negative, so we need to write our improper fraction as a negative as well, and I want to put it in front of the numerator. Okay, let's look at the next mixed numeral. We multiply first and we add second. What are we going to get? 2 times 2 is 4, 4 plus 1 is 5, so our numerator is 5 and our denominator is 2. The denominator stays the same, remembering that we're subtracting this fraction. Okay, so we've made them into improper fractions. The next hurdle we need to climb is to make sure that the denominators are the same. I can fix that by doubling the second fraction. I'm going to multiply both the numerator and the denominator by 2. Now the first fraction will stay the same. It stays as -7/4. Only the second fraction changes. 5 times 2 is 10, and 2 times 2 is 4. Now both our denominators are the same. We know that our solution will have a denominator of 4 as well, and we simply perform the calculation on the numerators. -7 minus 10. Now I cannot use my number line to work this out because I would be starting on the -7 and I need to move 10 places to the left, and eventually I'm going to reach -12 and I still need to move more positions. So what you need to do is you need to kind of imagine in your head where this number is going to land. It's going to land on -17. Anyway, we need to convert our solution into a mixed numeral now. How many times does 4 fit inside of 17? I can fit 4 into 17 4 times with a remainder of 1. And the denominator stays the same, so it's going to stay as 4. Remembering that our solution is negative, so my mixed numeral also needs to be negative. It needs to be -4¼ Let's now move on to our final question, question D. You'll notice that we're subtracting a negative, and we spoke about that earlier. When you subtract a negative, you can convert these two minus signs into a single plus sign. So let's do that first. Let's rewrite it as -2/3 plus 2 3/4. The next thing I want to do is I really don't want any mixed numerals, so I'm going to convert it to an improper fraction. We do this by timesing first and adding second. What do we get when we do that? 4 times 2 is 8, and 8 plus 3 is 11. So my second fraction is going to have a numerator of 11 and the denominator stays the same. It stays as 4. My first fraction will just remain the same as -2/3. Now I did mention earlier that when I have a negative fraction, I prefer to have the negative in front of the numerator, so I'll fix that right now. Okay, now the denominators are different, so I really need to fix it so that they have the same denominator. I'm going to multiply the top and the bottom of my first fraction by 4, and I'm going to multiply the top and the bottom of my second fraction by 3. That's going to make the denominators the same here. Looking at the first fraction, 2 times 4 is 8. To be more specific, it will be -8, and 3 times 4 is 12. Looking at the second fraction, 11 times 3 is 33, and 4 times 3 is 12. Now that both the denominators are the same, I simply look at the numerators and I add or subtract these numbers. So in this case, I'm going -8 plus 33. This will give me a numerator of 25 at the top, and the denominator stays the same. It stays as 12. Now, can I simplify this fraction? Well, I can convert it to a mixed numeral. Now, I've sort of run out of room here, so I'll rewrite it up the top. How many times does the denominator of 12 fit inside of the 25? Well, 2 12s make 24, which gives me a remainder of 1. And then the denominator stays the same, so I get the mixed numeral 2 and 1/12. Anyway, that concludes this video on example 1. Remember to read the description below for links to workbooklets that relate to this video.